We got our billet hub. This is going to be billet aluminum. We got bearing races that are already pressed into it. And we need to install our lug bolts, followed by the rotor hat. So the lug bolts go down into the big hole here. Now it specifically says not to use an impact on these. I'm going to just run them in with the 3/8 here. Okay, and then these are going to get torqued to 30 foot-pounds, and I'm going to flip this thing over just so I can show you what I'm doing here. I'm going to use the pry bar and go through the studs like this and hold, and that'll keep the hub from turning while I can torque on the back side, but since that's kind of underneath, it'll be a little bit harder to see that. Just make sure that the one I'm torquing on is not the one that I'm holding or prying against. I don't want to have any false torque here. Okay, we got that guy sufficiently torqued down. So the next thing, it wants us to clean out the inside of the bolt holes for the rotor with acetone, and then blow dry, and then apply red Loctite, and then we're going to torque to 15 foot-pounds. Funny that they give you a Allen wrench with them as if that's going to be any sort of torque reading. Looks like it's a metric 4. That means we're going to step down to a 1/4 inch torque wrench. Okay, and this is the rotor disc. Sits on there real nicely. And as always, we're going to start everything before we start tightening anything down. So what I'm doing is I'm just doing a line, a heavy thick line down the side of the bolt there. And of course, as it gets threaded in, it'll smear itself around. Since we're going through the hat of the rotor, I don't really need it on the very, very top of the threads, or up against the bolt head, I should say. Give you some more light. Okay, and then that's the last bolt we've got, so we're going to go ahead and start torquing these down. So as I'm tightening that, I'm watching the Allen wrench deflect and not the bolt moving. That's not really reassuring, but I made it all the way around, even with the double check. So that'll be ready to go on the truck after we pack the bearings on it. All right, well, we got the rotors all built out, and we need to remove the original brakes off the truck so we can get the new brakes put on. So we'll have to pull off the spindle cap, and we'll jump into taking off that stuff, and then we'll have to pack the new bearings and make sure they're all nice and greased up before we put them on the truck. But we'll jump over the truck and start taking that apart now. All right, so we've got the large caliper bolts that are down here and up here, and we will work on getting those off. Those are going to be 18 millimeters, and I'm going to use my stubby 1/2-inch impact in here to knock these guys loose. And then I have these little hooks that I've had in my toolbox for a long time, and they allow you to hang calipers without distressing your hose or any various parts. But we'll hang it up here on the control arm for now, and then we'll work on getting the rotor taken off. All right, so then the front side here, we've got a hammer on or press on cap. There it goes. I'll try to do that without crushing it. And then we have our cotter pin and our axle nut, and then the whole assembly should slide off. And this is just a locking collar. And then I don't remember what size that is. I'm gonna say it's like 27. And as you can see, I broke that loose by hand. It does not take a whole lot of force because you don't want to overload the preload on the bearings. Then we have a flat washer here, and that just kind of distributes the load on the center of that bearing. And then our outer bearing will come out, and we can keep it retained in the stack. And then just like that, we're going to pull this whole assembly off. All right. So this is our bearing pack here. I'm going to go ahead and set one of these rotors off to the side for now. So in the bearing package, we have a inner and outer and a seal. So like I said, we will need to thoroughly pack these bearings and make sure that everything gets properly lubricated. But just to show you where these are going to go, our inner bearing sits right there, and then the seal goes in on top of that, although I think it goes that way. And then our outer bearing, as you saw in the removal part, the outer bearing we're going to stick in the nose here, and then we'll do our same spindle nut as well. Hopefully you can still see that. So for now, we're going to get these bearings packed in, and we'll do the seal installation on the inboard side, and then we'll get this rotor ready to go on. All right, so we're going to jump into packing these wheel bearings. I actually have a really good video on this that I did probably like 15 years ago on my YouTube channel. We'll just do a quick recap on that, but I'm going to use some Mercedes wheel bearing grease that I've used in the past, and I have quite the collection of. It's this kind of bright green color, and this stuff works really, really well. So what we need to do is we start with We basically want to push grease laterally through the bearing until it comes out the other side. So you can just take now they make tools to do this job, but I've always done it by hand. But you basically are going to start with a big dollop on your hand, and you're just going to continually press down into your stack of grease over and over and over. And what that does is forces grease up through the rollers, and you can start seeing it come through the rollers there. Get a little bit more. Now you can see full penetration on 3 of those there. So we're going to continue to do that all the way around this bearing stack. And of course we're going to make a big giant mess. And that's okay. And when you run out of grease, you can always set the bearing into your rotor and get some more grease put on your hand. Now the reason you do it laterally and not just try to roll it is the rolling's not actually going to force grease into it. It's just going to smear it around, and you're not going to get adequate grease intake into the roller section there on the inner race of that. Okay, now once we get all the way around like we just did there, we can take some of this excess and just kind of work it into the inner area between the 2 races, and that'll just give us additional grease in there that if for some reason we start having some settling out or some grease breaking down, more in the middle never hurt anybody. In fact, I'm probably still going to add some more than that on the inside there. And like I said, I did force some extra grease down in there between where that bearing race sits. I may even still add yet a little bit more in there just in case. And then we'll put this, we'll wipe off a little bit of excess on the top side and push that seal in. Okay, and then we're just going to tap the seal in with a small hammer here. So we're right at flush. It looks like that's going to be the right mounting depth. Comparing the old rotor and the new rotor, new hub does not have the reluctor for the ABS. Not a big deal. I don't have ABS on my truck anyways. In fact, that's actually one of my things I'm wanting to delete the ABS valve block out of the truck to save some more weight as well. So just keep that in mind if you are doing this, that you're going to lose functionality of your ABS. We'll get this guy flipped over, and we'll get our outer bearing installed, which means we need to get it packed. So I will get to working on that. All right, well, I got the outer bearing packed, and I put some more grease down in the center as well. Obviously, you can't completely fill it because the spindle will need to come through there as well, but you can add a little bit extra in there. And this guy's ready to go on the truck. Now before I do that, before it actually goes on the truck, I do have plans to clean up the backing plate, and probably going to get a fresh coat of rattle can on it as well, just so it looks a little bit nicer. And so I'm going to unbolt that, which looks like just 3 8mm. That'll come off, and then I'll get it cleaned up and get it painted, and then we'll be ready to reinstall it on the truck. The website pictures, or the advertisement pictures, actually show it with the backing plate removed. But part of what I like about having the backing plate is having that little bit of an air duct here that actually helps draw some cooler air from the front end of the vehicle into helping cool the rotor off. So I don't really want to delete that if I don't have to. So I did my test fit to see if it would fit, and then the rotor is like locked up. It only moves a little bit, and I realized that on top of deleting ABS, the actual, see if we can see it down in there, the wheel speed sensor right there is actually just happened to line up with where one of the bolts goes through. And so we just have a little bit of movement back and forth. So the wheel speed sensor 100% will have to come out of here. But either way, sensor's got to come out, and then we'll finish our test fitting here. Because ultimately I didn't want to take the time to remove the backing plate, clean it up, paint it, prep it, all that good stuff, and then find out it doesn't fit. So this is why we're doing the test fit ahead of time. So like I said, we'll pull the sensor off and then we'll see if everything clears. And then the rotor is back off. So I did my test fit, and this little lip right here is hitting the back side of the rotor. So at a minimum, I'm going to have to cut and modify the backing plate. So after getting the backing plate removed and getting a closer inspection, it looks like this guy actually sits on top of the backing plate, and it looks like there was like a column or like a tower that came off of it. This sat over the outside of that, and then it looks like that was machined or pressed down onto. So it looks like this inner flange. If we just shave off that inner flange, then we should be able to just pluck the that ring clean off of it without actually having to try to cut around it. So had it in the vise, did some careful grinding, and you can see my lip starting to peel up here. So we're going to continue grinding until we can remove the rest of this, and then that cup should just come straight off after that. Alright, so I made it all the way around, and I got the ring completely removed, and there was just a little bit of tension, probably just from minor surface rust that had kind of glued these two dudes together, but overall came right off. So if you're doing this at home, you want to kind of cut at a 45-degree angle across the barrel like this, not necessarily like straight on. And that'll remove that lip as fast as possible without getting too much into the backing plate. So we'll get this dude test fit again, and then we'll get it cleaned up and painted if all the test fitting works out well. And if you've ever seen these type of little pointer calendars, you want to know what these are all about. This is the year 2003, so it's pointing at the 3. And then this is pointing at 9, so this is the 9th month, so September. And this is pointing at somewhere about 22, 23, 24, somewhere around there. So somewhere about September 23rd of 2003 is when this part was built. Let me start off with, I did a test fit after I removed the ring, and one of my bolt heads was just barely touching the back of the hub. So I dug around in my parts bin, and I found several bolts that look like they might be a little bit shorter head profile, but are going to be different matching sizes. So that's kind of frustrating. And then I found two bolts that are identical to each other. They're way too long, so I can cut these down to where they're the appropriate length. And then that should give us enough clearance where the head of the bolt is about half the height of the original 8mm bolt. And just like that, we have some new custom hardware. So we'll get the this is going to be a Torx 30 now, and we'll get the backing plate installed one more time, and we'll put our new low profile bolt in there and see if we clear. All right, and as you can see, so this guy's recessed and it's way out off to the side. This guy's recessed in this bowl shape, and this guy stands up off of that. So that's why we had an issue with this guy. All right, I've got my nut just hand tightened down. Finally got full rotation without hitting anything. Now let's take a look on that. Let's take a look on that back side and see how tight our fitment is. I'll probably still would like to bend this lip of the backing plate just a little bit, because man, we're just zero tolerance there. We can start to see the bolt head appearing, and it's really tight fitment, but we got a pretty good little air gap there now where we were actually hitting before. So I think if I just bend my backing plate out in that area, I think I'm going to be happy with that. Alrighty, and after doing some massaging here, we definitely have a lot more air gap. Looks a lot better fitment wise. Like I said, really happy with that fitment, and that means the backing plate can get reused, although you may choose not to, but in my case I'd like to keep it. even though I could probably argue that there's not a whole lot of airflow being as low as I am and as tucked up as that wheel sits in the fender liner. There's probably not a whole lot of air getting to it, but I think I would prefer to keep it. So we can get the backing plate back off, we'll get it cleaned up, wire brushed, and get it painted, and then we'll move on to the other side. All right, so my Summit package has arrived. I was looking through the instructions, and our caliper, where the brake hose connects into the caliper, is a NPT, which is a tapered pipe thread. And because of that, we're not able to use the banjo bolt because you can't have the threads tighten through the taper fit, and at the same time you're crushing the washer for the banjo. That's impossible. So got a couple different options here, and we'll do some test fitting once we get it once we actually get it on the truck. But I have let's see here, I have a NPT to AN3, which is this is a 45-degree angle, so we might use that guy. Same thing in a 90-degree. And then we have some AN to AN hoses here with the 90-degree head on them, and then this will be the brake line on the truck side, the frame rail side, which will be our tapered fit, and then goes to AN3. All right, well, we got the backing plate painted. Looks pretty sharp. Looks a lot better than it did. And we're going to do the final torque on the axle nut. So we're going to tighten the nut to preload the bearings while we're rotating the caliper. We're going to tighten that to 24 foot-pounds, and then we're going to back it off about a quarter turn, and then we'll do our final torque on it. Okay, and the final torque is actually 24 or 17 inch-pounds. My torque wrench does not actually go down that low, so we'll go to 24, which is not much different. And again, we're going to rotate as we're torquing this thing down. And that's it. Basically, that's going to be more or less hand tight, and we can check our in and out play. Just kind of grabbing, pushing, pulling, making sure we don't have any in play, and also then checking to make sure it doesn't feel too tight. And then if you need to get your cotter pin lined up, we can actually back it off just a scotch if we had to. This collar, the factory collar, actually has several different teeth configurations, so usually if you just kind of rotate it notch by notch, you'll find one that fits. And then we can put our cotter pin back in this guy, and then we'll bend our cotter pin and put our cap on. And I didn't really talk about it, but one of the nice things about this new kit is the cap is actually threaded. It's a machined cap as part of the machine part of the process of the rotor. So that's really nice that thread's on there, and it certainly looks a lot sharper than the hammer-on cap style. The next step, we're going to put our caliper on here. We're going to get that guy appropriately spaced in and out to make sure we have the rotor nice and centered on that caliper. And this particular caliper has a left-hand mark on it, engraved there, L1. If you are unsure, whenever you install your caliper, the bleed screw should be above your brake line, and that's just so that air can travel up and actually get bled. Alright, so at the caliper situated, without any washers, it's like perfectly centered, so we're good on that. However, I started running my top bolt in, and I'm like less than a millimeter of space away from the rotor there, even with the washer installed, and that's before torquing, complete torque. So I'm probably going to cut about 2 threads off of this bolt because it's Like I said, it's really tight and I'd rather not scratch up the rotor. So we'll get to shaving some bolts here. Kind of a bummer that brand new kit doesn't come with the correct hardware, but it is what it is. All right, so I've got 3 of the bolts in here. I've got 1 of them cut already, and the 4th bolt I have in my hand, and I'm just using that as a height reference so I can see how much material I've removed. So right now I'm about 2.5 threads, so that'll be just right. And then we can come back behind it with the smaller grinder and just kind of do a little feather, little 45 on that just to help make it get started easier. And so we'll get these 2 cut, and then once we get our finalized bolts, then we'll use that as a reference back onto the one that is uncut at that point. And now that we did the majority of the rough cutting, we can do some little bit of 45 action here to just kind of soften that edge up a little bit. And there we go. So we got 3 of them cut down. We can do another test fit before we commit to this length, but I'm pretty happy with the way those turned out. Okay, so we got the caliper bolted down, torqued it to 125 foot-pounds. There's different readings depending on who you ask online, but I figured that was good enough. And I think that should be just fine, but I went ahead and put in my center pin for my brake pads. Now, I'm not crazy about the work instructions for that. It just says tighten it until you can barely turn the bolt by hand. Basically, there's not really any access in here to hold that. And I did find a good use for that 4mm wrench that came with the kit, with the brake bolts. So this is a 4mm on this side. So what I did is I was tightening the nut down until I felt like we had just a little bit of friction on the head of the bolt. And then I called that good enough. Now this is a nylock nut on this side, so it shouldn't come out, couldn't back off or anything like that. The main thing is we don't want to break the tabs off the end of the calipers. So we should be ready to start playing with the brake lines next. So I will go ahead and break this side loose. Alrighty. So I just have my old caliper just hanging because it was still dripping, but it's ready to come out basically. But I ended up using the AN line, and I use the 90-degree fitting on this side here, and that will actually move my brake line further out of harm's way as well as closer to the center line, so I should have less deflection in it. Now I still need to do a articulation test. So I still need to do an articulation test and turn the wheels both directions and make sure my brake line doesn't have any weird snags or pulls or rub points or anything like that. I will also bring the suspension back up to ride height and make sure I don't have any fitment issues in with the lower control arm and where the bump stop is and all that good stuff. So I will do some homework here just to make sure we don't have any long-term fitment issues that are going to cause problems down the road. After this side is completely finalized, double-checked, verified, all that good stuff, then we'll move over to the other side, which I won't shoot footage for, and then we can bleed the brakes following all of that. All right, well, I got the passenger side all the way back together, doing my first test with this. This is with the steering all the way to the right side. And we can come in here and we can see that our brake line looks nice and happy here. And that's part of why I was wanting to get that that elbow closer to the center line, just so we have less articulation. You know, the further out it is, the more it swings in an arc in relation to the spindle. So we'll swing it all the way back to the left now and see what that side looks like. And we can also take a peek at our right side as well. Or I'm sorry, take a peek at our left side. We look good here. We didn't stretch too far. So we're looking good on that. And we'll go to the left here. Also had a message for the brake fluid being low because the brake fluid is low. So that's cool. That is one of the circuits that I did integrate. All right, so we're fully left. And we look good here. No interference with coilover or anything like that. Can live with all of that. And we'll go see what our passenger side's doing here. Oh, we look great over here as well. So maybe at some point I might want to do something just to keep this from rubbing, but as long as when we're driving straight ahead we're not touching, I'm probably not too concerned about a little rubbing. And this side is also at ride height as well. I do have it on the floor jack. The other side is drooping still, but shouldn't really change that much at this point. But just did want to make note of that. So I think I'm happy with this. We'll get to bleeding the brakes next. Anyway, so we're wrapping up on the truck, and I still need to bleed the brakes, but nothing you really need to see or know about. There's nothing special about that side of it, but I appreciate you checking out another video of mine, and I'll catch you in the next one.